two possibilities exist. We are either alone or we are not. If we are alone, then life is a miracle. If we are not, then the universe is full of miracles. For life to appear, three things must align: energy, elements, and liquid. Too much energy, and molecules are torn apart. Too little, and they freeze in place. Only in balance can chemistry come alive. Planets like Earth live in this balance, not too close to their star, not too far away. This narrow orbit is what scientists call the Goldilocks Zone. In this fragile harmony, light meets matter, and matter begins to move. Water flows, elements mix, and the first spark of life becomes possible. Across the galaxy, there may be countless worlds like ours, each with its own version of just right. Because where balance exists, life sooner or later learns to begin. Everywhere we look on Earth, life has found a way to survive. In boiling acid, in frozen glaciers, even miles beneath the sea. But how did it all begin? What recipe turned simple chemistry into biology? To build life, the universe needed three ingredients: energy, elements, and liquid. Energy provides motion, the spark that keeps chemistry alive. From sunlight to volcanic heat, it powers the reactions that build complexity. But too much energy destroys what it creates. Too little, and molecules stay still. Only a steady rhythm allows new structures to form. Next come the elements. The universe began with only hydrogen and helium. Everything else, carbon, oxygen, sulfur, iron, was forged in the hearts of dying stars, then scattered across galaxies like seeds. These heavy elements are the letters of life's alphabet. And finally, there must be liquid. In gases, atoms move too fast to connect. In solids, they are locked in place. But in liquids, they can drift, collide, and combine, the perfect playground for evolution. Here on Earth, water became the great dissolver, mixing chemicals into endless combinations, until one day, a molecule learned to copy itself. From that moment, chemistry became life, and the universe, for the first time, opened its eyes. Not all planets are created equal. Some orbit too close to their star, scorched by relentless heat. Others drift too far, locked in eternal ice. But in between lies a narrow band of possibility, a region where temperatures are just right for liquid water to flow. Scientists call it the Goldilocks Zone, named after the fairy tale of a girl who sought what was not too hot, not too cold, but just right. Within this delicate range, a planet can hold oceans that neither boil away nor freeze solid. Here, chemistry is free to move, mix, and evolve. Our Earth is the finest example of this balance. Orbiting 93 million miles from the Sun, it sits perfectly within this cosmic sweet spot. If Earth were a little closer, its oceans would evaporate like those of Venus. A little farther, and they would vanish beneath ice, like Mars. But in this thin middle ground, our world found its rhythm. The Goldilocks Zone is more than a distance. It's a symphony of conditions. The right atmosphere to trap warmth, the right mass to hold gravity, the right rotation to stir the winds and tides. Each note must play in harmony for life to begin. Across the galaxy, telescopes have revealed thousands of worlds orbiting other suns, some glowing within their own Goldilocks zones, each one a potential stage where nature might attempt her miracle again. The more we look, the clearer it becomes. Earth is not alone in being just right. The question is, how many other worlds have found their perfect balance and learned to breathe? Among all the planets we know, Earth is different. Not just because it sits in the Goldilocks zone, but because so many other factors came together at once. Our world didn't just find balance. It won a cosmic lottery. First, our moon. Formed by a colossal impact billions of years ago, it stabilizes Earth's tilt, keeping our seasons predictable. Without it, our climate would lurch between chaos and ice. Next, our magnetic field, a shield forged by molten metal in Earth's core. It deflects deadly solar radiation and guards our atmosphere from being stripped away. On worlds without this protection, like Mars, the air is long gone. Then, there's our atmosphere itself, thick enough to trap warmth, thin enough to let sunlight in. It carries oxygen for life and water for weather. Every breath we take is a reminder of how fragile that balance is. Our position in the solar system also matters. We orbit a stable, middle-aged star, not too violent, not too dim. Nearby gas giants like Jupiter act as cosmic guardians, their gravity deflecting asteroids that might have destroyed us. From the size of our planet to the chemistry of our oceans, every detail aligns with improbable precision. It's tempting to think Earth was chosen, but perhaps it's the opposite out of countless worlds. One finally had the right conditions, and we are its proof. We are the lucky ones, born on a planet that learned how to live. "4 billion years ago, Earth was a different world. The skies were thick with volcanic ash. Lightning flashed through toxic clouds. Oceans boiled with minerals and heat. There was no oxygen, no plants, no sound, only chaos. But within that chaos, the ingredients of life were stirring. Energy from sunlight and volcanoes struck the oceans, breaking and rebuilding molecules in endless combinations. Carbon met hydrogen, nitrogen met oxygen, simple atoms forming more complex structures. In the deep ocean, at cracks in the Earth's crust, superheated water mixed with minerals, creating natural chemical reactors. Here, the first organic molecules may have been born. And then, something extraordinary happened. Among trillions of random reactions, one molecule found a way to copy itself. It didn't live. Not yet, but it carried information. And that changed everything. Replication meant evolution. Mistakes in copying led to diversity. Some versions survived longer. Others vanished into history's void. Nature was running its first experiment, and it worked. Over time, These self-replicating molecules joined to form membranes, creating the first primitive cells, tiny bubbles of chemistry that could grow, divide, and compete. The line between non-living and living blurred, and from that blur, life emerged. What began as random chance became organized purpose. The universe had invented memory and life's story had begun. But this was only the beginning. What happened next would transform simple chemistry into the first living world. In the darkness of ancient oceans, nature began its greatest experiment. Atoms started to organize, evolve, and remember. Join us in the next chapter, The Chemical Dawn, where the universe takes its first breath as life begins to awaken.